Vanakkam! Welcome to my YouTube channel. Today we are going to learn about transistor configurations. If you want to learn about transistors and its fundamentals, please check out my other video about transistors. To run any electronic component, we need 2 pins for the input and 2 pins for the output, making it 4 pins. But the problem with the transistor is that it only has 3 pins. This is where configurations come in. In each configuration, we use 1 pin as common between the input side of the circuit and the output side of the circuit. So there's 3 types of configuration. First one being common emitter, and in this the emitter is common between the input and the output. The base is common in the common base, and the common collector, the collector is common. First we'll look at the common emitter. As you see, this is a circuit for the common emitter. So the input side consists of the emitter base junction, and this junction is always forward biased. So VBE, the voltage between the emitter and the base, is the input voltage, and the emitter current is the input current. So going to the output side consists of the emitter and the collector. The voltage for the output is VCE, the voltage between the collector and emitter. That's the output voltage. And the output current is the collector current. So as you see, the emitter current and the base current equals the collector current, but the base current is really small. So we just say the emitter current equals the collector current. So there isn't much of a current gain, but there's a good decent amount of voltage gain because we're adding the input voltage and the output voltage. So this is why we use a common emitter as an amplifier. So next we'll look at the common base. So as you see, the base is common to the input and the output. So the input side of this consists of the emitter base junction, and which is also forward biased, and VBE, the voltage between the emitter and the base, is the input voltage, and the input current is the emitter current. So going to the output side is base and the collector. So the output voltage is VCB, the voltage between base and collector, and the output current is the collector current. So as you see, the same thing with the common emitter configuration. The emitter current plus the base current equals the collector current, but the base current is really low, meaning that the emitter current just goes to the collector current, and this is why we use the common base as a switch. Next is the common collector. This configuration is used least because of the way it works. So as you see, the collector is common, the input side is a collector and the base, and as we saw, the input side is always forward biased, but in this case it's reverse biased because it contains a collector, and the collector is always reverse biased. So VBC, voltage between base and the collector, is the input voltage, and collector current is input current. So going to the output side, the collector and the emitter, and VEC, VEC, the voltage between the collector and the emitter is the output voltage, and the output current is IE. As you see, the collector is also on the output side, meaning this is also reverse biased. So since both of the sides are reverse biased, this is why it isn't really used. So next we'll look at the similarities and next we'll look at the characteristics graph. The characteristic graph is basically the relationship of the current and the voltage, which is shown in a pictorial way. So as you see, this axis is the voltage and this axis is the current. So as you see, the current is 0 until the voltage comes somewhere around 0.7, which is the barrier voltage of a semiconductor transistor, and after the 0.7, the current rises up constantly because it is forward biased. So for the output, as you see, this is the collector current, this is the collector emitter voltage, or the output voltage. So as you see, the collector current rises to a number, like let's say 10, and then it stops rising and it goes constantly. This is because the emitter current is flowing to the collector current, and when the collector current gets it just stops rising. Next we'll look at the similarities and differences. The common base, or CB configuration, can be used as a switch but the common emitter configuration is used as an amplifier. The common collector has a 100 degrees phase shift. Well, what is phase shift? Phase shift is when the polarity reverses. So from the input, the polarity reverses when it comes to the output. And 180 degrees phase shift means the polarity has reversed completely from the input to the output. While CD or common base has 0 degrees phase shift, meaning the polarity does not change. So that's it for this video, guys. I hope you liked it. If you liked it, subscribe, share, like, and hit the comment button, hit the notification bell. Nandri vanakkam.